Alright guys, welcome to a new series based on MCP STDIO based desktop agent orchestration, which basically means we're going to have an AI agent orchestration which will be connecting to MCP servers for tools, and those MCP servers will be STDIO transport based, which means with MCPs, we have two different types of transport. One is SSE, which is server sent event, which is based on HTTP protocol, and it can communicate over the web. But this STDIO is based on the operating systems or the desktop's own standard input output, which pretty much means the communication stays local. That said, if you've been following this channel, you know this structure of orchestration where we have a mission controller, and this guy takes the message from the user and tries to interpret what this is about. For example, I want to buy a laptop. When the user says that, it goes ahead and understand that this is product related. So it's, as an intention, it's going to put product in there. It's going to include the context, for the next AI agent to interpret or go to action with it, and it's going to have a confidence level saying how confident it is based on its decision. And as you can see, we have product in there, just like we have product agent, blog agent, recipe agent, and unknown agent. So based on its understanding, it's going to keep changing this text here to, let's say, blog, recipe, or if it doesn't understand what this is about, it's going to go ahead and put in unknown in there, and then it's going to go ahead and pass this decision object to this router node. And this router node, with the help of conditional edges, it's going to go ahead and reroute the traffic to either product agent, blog agent, recipe agent, or unknown agent. And when I say traffic, I also mean the global state of the graph, which holds this kind of information, decision information, or anything else we want to pass along to our agents. Now, previously, when we worked with this structure, our modular React agents were independent. Basically, what I mean is they had their own tools etched inside them. This time, it's going to be different. This time, for each of the agents, we're going to have corresponding MCP server. For example, for product MCP, for blog MCP, for recipe, the recipe MCP server. And they're all going to have STDIO or standard input output transport. And this time we're going to take a test driven approach, which means every module, every block we add to this whole thing, we're going to test them individually. For that reason, I took out all the tools from our MCP servers and put them in a separate bucket so that we can test them individually and then connect to the MCP server, thus connect to the product agent, so on and so forth. And when we create these tools, they're going to be talking to external APIs. Here, as you can see, is the product API, blog API, recipe API, right? So let me show you where they're coming from. All right, so this is what I'm talking about, dummyjson.com. This is what we're going to be using as API endpoints. They're very simple, they're free, and requires no kind of API key crap, which I didn't want to handle because this is strictly an educational project. If you go to their GitHub, you'll see they have 190 products, 200 users, 250 posts, 50 recipes, etc., right? And this is what their API looks like, very real looking and fast. Also, they have excellent documentation. Let's say if you're working with product, this is where you go to get the product info, single product, search product, pagination, etc., etc. This is really an excellent API to get some prototyping done. That said, let's go back. All right, so all that being said, I'm just going to say that I'm not going to dump everything on you on just a few videos. I'm going to go step by step, take one small bite at a time, by which I mean, let's focus on just the product agent, its MCP tools, and the product API. Let's zoom in to this block right here. All right, so this is how a single desktop agent workflow works. So basically, first, we focus on building our tools. based on this product API, we create list products, search products, list categories, get product by categories. All these functions will be our tools, but at this point they remain only functions. And then based on these, we create test functions and use PyTest to test them all. Basically automate the testing process. Once they are tested successfully, then we spin up our MCP STDIO server, which then pulls in these functions and convert them into tools. And it will make more sense when we go to the code. But please sit tight for now. So then we individually bring this server up and then move to creating our product agent. At this point, we create just a regular agent, not a modular React agent. And there's a big difference, because if the agent code is not modularized, then we cannot add that to our graph. So anyway, all that will be much more clearer when we go to the code once again. So for now, just hear me out. We then test this regular agent against this MCP server using these tools individually, just this block right here. And once that is successful, that's when we take this agent and make it modular and attach it to our LangGraph rig. And this time we're going to follow the prompt nexus model. This is another thing that if you're following this channel, you'll know about. But this is our earlier workflow before we implemented the mission controller based agent orchestration. So anyway, at this point, we attach our product agent via conditional edge to this graph and then turn this graph into a runnable graph. And then we create main.py, which is a simple chatbot which implements our runnable graph. With that, we go to user start up this main.py and gets presented with a chatbot loop, and user can ask questions, and then it goes to this LangGraph graph and via the conditional edge goes to the product agent. Product agent then uses this MCP server to access the tools, and these tools then fetch the data from the API and bring them all the way back to the user. And I missed mentioning that before we attach our modular agent to this guy, we test this guy separately. Then we attach our modular agent via conditional edge to this guy and then test this graph separately before we turn this into runnable. And after we test successfully, that's when we attach it to the chatbot. Basically, what I'm trying to say is every step of the way, we have to test each block separately. Only then we can hope for any success at this level. And that being said, once this rig is a success, once we have successfully connected one agent, product agent, to our LangGraph, then we move to the next step. All right, so the next step is going to multi-agent with MCP tools, which pretty much means now that we have success adding one agent, product React agent, via conditional tool to our prompt nexus LangGraph. So we kind of have a repetitive structure here: React agent, MCP server, product tools, and product API. The same way, we're going to now attach a conditional edge for our blog agent, then add this blog React agent, which will talk to blog MCP Studio server, bring in the blog tools, and talk to the blog API. Exact same way. Recipe agent, just the same way. Recipe conditional edge will bring in recipe agent, recipe MCP tools, and recipe API. Meanwhile, our prompt nexus, which is the main chatbot node, will have its own end node connected. So anytime it receives a request that doesn't meet any of this conditional logic, it's just going to go ahead and answer the user. Otherwise, all the traffic will be rerouted to the appropriate agent. So once we tested this rig successfully, then we can go back to this original structure. As you can see, this is exactly the same. Only new thing is this unknown agent, because we need this guy to help out with our new routing system. We now take this block and simply replace the prompt nexus with mission controller, router node, and its new conditional edge based on this decision object. Finally, we test everything and we have a finished product. Now, all that being said, you might be wondering, what is the use case? Which I did actually. Like, what is this local crap that we have to deal with? Why not HTTP? So to answer that, I have something to finish this video with. Let's go there. Alright guys, so this is the use case I could think of for our STDIO based desktop application deployment. Our application, as you can see, we have two parts. One, what we are working on, our rig, will be completely Python based, which we will eventually turn into an API server based on LangSmith. And the other one would be the application front end, which we will use Electron Builder to build. Electron Builder is basically a desktop front end builder using the web technologies. If you don't know about it, please, I urge you to Google it. So anyway, we take our backend, LangSmith based backend, which is also Python based, and use Python installer to create an installer for it. And then we take our Electron based front end and use Electron Builder to give it a desktop installer package. We take these two packages and then we further orchestrate them and create a package bundler. For Windows platform, we use Setup that creates this kind of setup interface and installs everything step by step. And for Apple platform, we find a PKG installer package to bundle up both parts of our desktop application. With these, we install our package to the desktop. It could be on Windows or Mac or Linux, whatever. So once we install the package, a successful installation would mean our backend will start up using localhost and some ridiculous port that very uncommon and only we will use and we will know about. And that will give us the API which our Electron-based front end will use. So every time our desktop user sends a request, our desktop front end, Electron-based desktop front end, makes a request to the Lang server, the LangSmith server, and using our orchestration that we just talked about, we will give it tools like, for example, to reach external APIs, local applications, local file systems, system processes, local JSON data source, or local database. With all that tool, it will be able to answer all the necessary questions our desktop user might have. Now, here is another angle to it. If you are building an Office application which has a local area network or LAN server, you can take that LAN server, install Ollama on top of it, and then deploy a bunch of open source models, which will then connect to your API server. And at this point, if you're only working with local stuff, you're not even going to need the internet. All your work will keep going using the local model, completely independent of the internet. At this point, you might lose these external APIs, but guess what? If you're smart, you're going to be implementing a caching mechanism, like let's say some sort of a cron job that will keep making calls to this API in a time interval and write them to local data sources like JSON or in a database, so that even if you are disconnected from the internet, your data is still accessible, all cached using the local Ollama models. Your business goes on and on. That, my friends, could be your use case for building a rig like that I'm building. That being said, from the next video, we go straight to work. Until then, thanks for watching.